Molecular spectroscopy, graphology of molecular dance. Chemistry aims to identify and characterize molecules and compounds and understand their properties and transformation. During a chemical reaction, the bonds between atoms rearrange to form new groups of atoms, new molecules. If chemical bonds were rigid and static, then no chemical transformation would be possible, and that is not the case. Bonds, acting like ideal springs, would stretch indefinitely, but in reality, if we expand bonds too much, they break. When molecules move around, they rotate and vibrate. There is much richness and detail in this molecular dance. Ideally, we would like to observe the molecules directly, but this is not possible even with the most powerful microscopes. Molecular spectra can provide indirect information about the motion of molecules. So what are these spectra? White light consists of many colors with different frequencies. When molecules rotate and vibrate, they absorb some of the frequencies. This can be represented as a spectrum. Chemists then collect these spectra for future reference. When an unknown molecule is found in nature, we can infer some information about its structure by comparing its spectrum with our database. The spectra of molecules are also affected by the environment around them. For instance, in gases, the molecules move freely, unaffected by the other molecules. However, in liquids, the interactions between molecules are stronger and their movement is impeded. In solids, these interactions are even stronger and the molecules are unable to move away from their positions. As an illustration, let's look at the spectrum of water vapor. As you can see, the rightmost peak is shifted in liquid water due to the interactions between molecules. In ice, the peak is shifted even further due to stronger interaction. Computational chemists try to decode these signatures by creating models approximating the motion of molecules. In other words, they do graphology of the molecular dance. These models also have to account for quantum mechanics, which causes bizarre things to happen. For example, large particles cannot move through barriers unless they manage to climb over. However, atoms, due to their quantum nature, can tunnel through even the highest barriers. Our current models can get some aspects of molecular spectra right, but understanding the effects of quantum mechanics on molecular motion is very difficult, and there is still much research to be done before we can finally crack this problem.
Hi, I'm Vijay.
And I'm Adam.
We hope you liked our video. We are here to say a few words about our animation and our research. Molecules in nature move about in their surroundings, which enable them to participate in chemical reactions. Their motion leaves a quantum mechanical footprint. In our group, we try to analyze these footprints and understand the chemical properties of molecules. Our video, which was produced in collaboration with Shana, outlines various aspects of molecular motion and the ways to observe and interpret them.
Apart from giving us understanding of the physics of molecules, the computational methods that we develop can help both in analysis of existing compounds and materials, as well as in discovery of novel ones. In some cases, it may mean that fewer expensive experiments are necessary. In other cases, we may calculate data unobtainable by experimental means.
We hope that our film offers a glimpse into the exotic world of molecules. We also hope that our animation conveys how researchers catch molecules in the act as they move around and undergo chemical transformation.
The project was both enjoyable and challenging. It was a joy to see scientific concepts come to life in the animation. At the same time, it is very difficult to make a video which is both accessible to the general audience and scientifically rigorous. This ability to explain research in an engaging way is the main thing that we learned during this project.
Thank you.
Thank you.
Hi, I'm Shana and I created the animation for Vijay and Adam's molecular spectroscopy project. I'm presently studying media and graphics at Long Road Sixth Form, but my aim is to study animation at university. The Creative Encounters project has given me a fantastic opportunity to use my imaginative and creative skills whilst working with a real-life brief. It's been hard work and challenging, but the experience has been phenomenal. The process started with online meetings which resulted in me producing a storyboard. Vijay and Adam then helped to develop the storyboard further so that the animation was scientifically accurate. The project taught me the importance of managing my time wisely and the importance of communication between the team. I'm proud of the animation that I've produced and thankful for taking part in the project.